Hello, this video tutorial focuses on the processes and landforms at divergent plate boundaries. It also introduces us to the processes and activities that occur at plate boundaries. This tutorial focuses on two major things. The first is what characteristics are important in figuring out the type of plate boundary. And the second is what's happening at divergent plate boundaries and what types of activity and features occur there. So I think I've mentioned before that in general, geologists don't go out in the world to try to identify a plate boundary and find a nice set of signs that identify it for them, or an arrow or a set of arrows or anything like that. And maybe you've gathered from the book that we also haven't measured actual plate movement for very long. And in fact, that's a really expensive and time-consuming sort of project. And so since the very beginning of understanding the theory of plate tectonics, plate boundaries are usually identified by the unique tectonic processes and characteristics that are at each of them. So each type, and sometimes each subtype, that is, sometimes the type of crusts meeting, matters in what kind of features you get. So each type's going to have sort of a unique signature, kind of like its fingerprint. So we're looking at two things, what are generally called tectonic processes, and then characteristics or landforms that occur there that are signatures. So take a minute, please. Think about what we might be meaning by tectonic processes, and then tectonic characteristics or landforms. What might go in different places? So let's start with tectonic processes. There's several, and I've included maybe more here than we really need, but I'm hoping you can make these connections. So melting or magmatism, anytime rock melts in a location, that is considered melting here. Earthquakes, and what we're going to notice is earthquakes occur at different depths, and they tend to have a different maximum magnitude that can occur at different plate boundaries. A third tectonic process would be mountain building, and we refer to this primarily on continents, so on land is the way it's sometimes called. Continental rifting. Rifting means pulling apart, so rifting on continents. Seafloor spreading, the seafloor actually spreading apart in certain locations. Subduction, you probably know the definition of this already, and we'll review it later as well. This is when one piece of lithosphere, it has to be oceanic crust on the lithosphere, descends underneath another piece of lithosphere. So one plate that's made of oceanic crust descends into the rest of the mantle, into the asthenosphere, underneath the other tectonic plate, which can be oceanic or continental in terms of its crust. Collision, two continents colliding together, or two plates with continental crust colliding together. And faulting, again, we'll go over this again shortly. For now, know that this is where rocks break. This is intimately related to earthquakes. So where faulting occurs, usually earthquakes occur, and vice versa. The other aspect of what we're looking for are specific landforms, and you're going to notice there's some very strong relationships here between processes and landforms, and in fact it might get a little bit redundant. However, we're going to list them separately because this is usually the way they're discussed in part, and we want to make sure we're not missing anything. So common tectonic characteristics or landforms include volcanoes, and you've already looked at lab different patterns of where the volcanoes occur, and volcanic activity. So volcanic activity basically means the same thing as melting. Again, we're kind of crossing back and forth here, but trying to hit all the bases. Earthquakes can be considered a characteristic or a process. I think we're mostly going to list them as process from now on. Sometimes they are listed here as characteristics. Faults, breaks in rocks, go along with earthquakes, occur by the process of faulting. Mountain ranges on land. Again, mountain building on continents is a part of this. Mid-ocean ridges, or sometimes just called an ocean ridge. This is a very important feature to know. The other really important feature or landform to know are deep ocean or ocean trenches. And one more is something called a rift valley. We'll describe these to you and give you some examples. I want to let you know that there's a table with this information available for filling out on e-learning, and I would highly recommend it as a way to review. I also want to remind you, only recently have we been able to track plate movements in real time and measure them. It's expensive, time consuming. We don't do this everywhere. We still rely on these characteristics and processes to identify what type of plate boundary is occurring. So we've mentioned this relationship between earthquakes and faults. I want to remind you that earthquakes occur when brittle rock, so that has to be maybe a particular layer you're thinking of, brittle rock, breaks along faults. And faults are cracks in rocks along which movement occurs. So now let's see if you can answer this question. Which earth layer has earthquakes? Choose the single best answer. Go ahead and pause while you're working through this, and then come back and we'll give you the best answer. All right, did you come up with the answer to which earth layer has earthquakes? The best answer is going to be lithosphere. So this is going to be in the crust and then that uppermost part of the mantle. So both of those. So recall that lithosphere is what makes up tectonic plates. So the whole tectonic plate, anywhere in there, can experience earthquakes. So earthquakes are going to be occurring in the brittle rock of the lithosphere, or the tectonic plate. And a few things to keep in mind. The size or the magnitude of the earthquakes, how much energy is released, this depends on the thickness of the lithosphere in any particular location. So in general, the thicker the lithosphere is in that location, the bigger the earthquakes possible. The depth of earthquakes also depends on the depth of the lithosphere, sometimes the thickness of the lithosphere. But if we're talking subduction, then it's not so much its thickness from sort of top to bottom, but where it is. How far does it extend down into the earth? So in general, deeper lithosphere means we're going to get deeper earthquakes. So it turns out that each type of plate boundary is marked by a line of earthquakes, but each one has a unique pattern of earthquakes, or at least pretty close to it. So what you need to be able to do after practicing and studying and hopefully working your way through this tutorial is you'll need to be able to explain why divergent plate boundaries on land become divergent plate boundaries in the ocean. Explain the formation of landforms at a divergent plate boundary on land, so on a continent. Explain why most divergent plate boundaries are located in the ocean, so in oceanic or ocean crust. Describe two characteristics of divergent plate boundaries in oceanic lithosphere, so in the ocean, and the processes that create them. Explain the formation of landforms at a divergent plate boundary in the ocean. So a bit of review, something you probably already remember, but just in case, divergent boundaries occur where two tectonic plates are moving away from each other. So we can see this in the cross section in the map view, and one thing to keep in mind is the lithosphere gets really, really thin right there at the plate boundary. So major processes that are occurring at divergent boundaries in the ocean include seafloor spreading, magma formation, and new oceanic lithosphere formation. So let's take a look at some of these processes. So some of the processes occurring here that relate to magma formation are the asthenosphere, which is the not brittle but ductile layer of Earth, is able to rise in this area as the tectonic plates pull apart. That rising, weirdly enough, actually causes melting in the asthenosphere. That magma being under less pressure and also being less dense than its solid counterpart rises up where the plate boundary is located. It can solidify there underground, or it can erupt as lava. At the plate boundary itself, this is a high area. It's kind of buoyed up by the fact that it has this ton of hot asthenosphere rock below it. So it's elevated high above the rest of the ocean floor. This is called the ridge. And the ridge is split in two by the tectonic plates moving away from each other. The process of that pulling apart of the lithosphere right at the plate boundary, splitting into the two pieces with new oceanic lithosphere forming from the magma in between, that's called seafloor spreading. So one question that comes up often is after you've had a chance to look at some examples of these plate boundaries in real life is, are there actually volcanoes at the ridge? And in some places, definitely yes. They're mapped, we know about them, but it turns out we know so little still about specifics of the ocean floor that a lot of places there probably are volcanoes. We just don't know where exactly they are and what they look like. Something else to keep in mind is the ocean floor is actively splitting apart at this point, at this area. So growing a huge volcano like we might see on land, volcanoes probably don't look the same under most circumstances. Sometimes there are ones that grow up and they can be islands and very rarely make islands, but often make not quite making it to islands called seamounts. However, these are not often going to show up on the Google Earth kind of database. The database that we pull from is a international database, and we just don't know where those volcanoes are located a lot of times. So I'm going to insert here a short video clip that is an animation put out by this research group that also works in education called IRIS. I find the music to be a little bit annoying, but take a look through. If you would like to watch it with subtitles, which makes it a little bit easier to catch all the terms that they're using, then there's a link to this on our course website next to this video, basically, that you're watching.
At divergent margins, lithospheric plates move in opposite directions. The plates, which include crust and part of the upper mantle, ride over the asthenosphere. As hot mantle rock rises to shallow depths, it begins to melt due to lowered pressure. This forms magma. Dense plutonic rock is created as the magma is injected into the crust. Small magma chambers form low in the crust. Less than 1/4 of the magma ever reaches the surface to erupt as pillow lavas. As it moves away from the ridge, the cooling rock sits progressively lower than the hotter, more buoyant rock at the ridge. Like two giant conveyor belts, the plates transport newly formed oceanic crust away from the ridge crest at 3 to 10 centimeters per year.
So a characteristic to know that we've mentioned before is that the lithosphere is very thin at divergent plate boundaries. So what this means is that earthquakes are going to be very shallow and they don't have the capacity to be very large. So we say a small m or a small magnitude. It doesn't mean that they can't cause damage, but they tend to be around magnitude 6 or less. If you've heard of magnitude referring to the Richter scale, that might mean something to you. Really large earthquakes are in the 9s. Or above, and then small earthquakes that we can barely feel are in the 3s and the 4s. Most divergent boundaries are in the ocean, so let's take a look at this map. You'll notice the divergent boundaries are here in red, so most of them, nearly all but not quite, are sort of in the middle of oceans or splitting continents apart. And this is because oceanic lithosphere is created by that process of seafloor spreading, easy for me to say, at divergent boundaries. So perhaps you can notice one divergent boundary on land. This is a boundary that is not in every map and every textbook yet. Luckily it's in ours, and this is called the East African Rift. And then there's two that are nearby, you might notice, and one has a lot of segments of transform boundaries in between, and the Red Sea around Saudi Arabia. Okay, so let's get oriented here. This is the kind of screen we're going to be looking at for a little while for all types of plate boundaries. And right now we're trying to ask the question, what tectonic processes are at divergent plate boundaries? And specifically we're looking at those that occur in these spreading centers in the ocean. So we'll look at continental boundaries very briefly, divergent plate boundaries. So our list of tectonic processes includes melting or magnetism and exactly where it occurs in relation to the plate boundary. Earthquakes, recalling that they have different depths, slightly different locations, and different maximum magnitudes depending on the kind of plate boundary. Mountain building on continents, another process. continental rifting, seafloor spreading, subduction, collision, and faulting. So let's walk through these and see which is appropriate for this kind of plate boundary. So do we have melting here at divergent plate boundary in the ocean? We do. Melting or magnetism, and if magma is being made, so on our diagrams, these orange blobs, if you see them there, that means at these type of plate boundaries, magma can be made. It is occurring right along the plate boundary at these types of divergent boundaries. Earthquakes occur at all types of plate boundaries. In this particular case, we've already mentioned the lithosphere is very thin, only shallow earthquakes, usually fairly low magnitude, usually 6 or less magnitude, and also notice that they are located right along where faulting would occur, right along the plate boundary, with these little stars indicating possible or likely locations. So they're going to cluster very near to the plate boundary, and they're going to be shallow in depth. So next on the list are two tectonic processes that are not going to be occurring here at divergent plate boundaries in the ocean because they're specifically referring to processes that happen on continents, and that would be mountain building on continents and continental rifting. So we have no continental crust here, so neither of these processes can occur. A process that we do have occurring here at divergent plate boundaries in the ocean, or oceanic divergent plate boundaries, is seafloor spreading. So recall seafloor spreading is the seafloor cracking open, pulling apart to either side, and new seafloor or oceanic lithosphere forming in the middle. So indicating the plate boundary, this is occurring right at the plate boundary, and the process is called seafloor spreading. Subduction is when a plate with oceanic lithosphere moves downwards into the asthenosphere underneath another plate. That is not occurring here. That only occurs at some kinds of convergent plate boundaries, not at divergent plate boundaries, so no subduction. How about collision? Collision is when two plates of continental lithosphere crash into each other. Again, no continents anywhere here, so no collision. How about faulting? Faulting is rocks breaking, basically, and this is associated with earthquakes. So if you've seen patterns of where earthquakes have occurred or do occur at these kind of plate boundaries, that's also where faults occur, breaks in rock. So let's take a look now at tectonic characteristics or landforms that occur at divergent plate boundaries in the ocean. We've reduced the list just a little bit to eliminate some unnecessary overlap with processes, but you might still notice a little bit of overlap. That's okay. Volcanoes. So let's take a look first at volcanoes and volcanic activity, and a reminder, if magma is being made, that's melting, and that is considered volcanic activity. So our volcanoes or our volcanic activity, since we might not actually see big volcanic landforms, is occurring basically directly along the plate boundary, right in the confines of the mid-ocean ridge here. How about faulting? We have already indicated this along with faulting, and so I guess I should have said, how about faults? So same answer. Faulting produces faults. The faults are the features produced by rocks breaking. They're going to occur in the same places earthquakes are. How about mountain ranges on land? In this case, on land basically means on a continent. So with no continent, no mountain ranges on land. How about a mid-ocean ridge or an ocean ridge? Yes. This is the feature that marks the plate boundary location, and it consists of uplifted, very hot, very buoyant oceanic lithosphere. This is called the ocean ridge or the mid-ocean ridge. It's kind of these two little twin peaks. How about an ocean trench or a deep ocean trench? A deep ocean trench is a deep V-shaped valley at convergent plate boundaries, so it doesn't apply here. How about a rift valley? A rift valley is a long depression on land or on the continents. So again, not on land or not on a continent, so isn't going to apply. No rift valley here. So let's now compare what we've learned about divergent boundaries in the ocean or oceanic divergent boundaries to divergent boundaries occurring in the middle of continents. So divergent boundaries on land, similar processes and features. One thing that is present here on land that will not be present if you're in the ocean is instead of a mid-ocean ridge, we have a rift valley. So a long, low area that forms as the lithosphere thins and is split apart. Basically, we go from one plate turning into two plates and moving apart from each other. And as that occurs, the lithosphere gets very thin. And in fact, Oceanic lithosphere, if you can see the sort of gray stripe in the middle, is what's starting to be formed in this image. So again, we get the rift valley rather than the ridge. As far as processes go, then this is very similar. We have fundamentally the same processes. We have melting near the boundary. We have earthquakes that are going to be relatively shallow, although the lithosphere can be a little thicker here on land than we have in the ocean with oceanic lithosphere. Still, the earthquakes are confined to a fairly shallow area. We do not have mountain building on continents. We do have continental rifting. So rather than sort of building the landscape up with mountain building, we're actually pulling it apart, making these large, flat, depressed, lower down elevationally areas. We do not have subduction. We do not have seafloor spreading. We do not have collision, but we do have faulting where those earthquakes are occurring. So we got an idea of what processes are occurring. How does this relate to features? We do get volcanoes near the boundary. I'm trying to point them out here. They're very tiny in this picture. And that counts as volcanic activity. We do get faults. It's basically these diagonal lines as the crust breaks apart and the lithosphere breaks apart. We do not get mountain ranges on land. Again, we don't get a mid-ocean ridge. We get the rift valley instead. We don't get a deep ocean trench. So one of the questions we're asking you to try to get a handle on is, why are most divergent boundaries in the ocean? And so the idea is most of the time divergent boundaries, well, they can start anywhere, on land or in the oceans, but if they start on land, eventually they are actually forming new oceans. So this is kind of a cool thing. All of our modern oceans were formed when the last continental breakup occurred. If you've heard of Pangea, that is not the only time the continents have all been together, but just the last or the most recent time. And it ended about 150 million years ago when they were all together. So it sounds like a long time, that it actually isn't in the history of Earth. So divergent plate boundary forming, actually several of them at slightly different times throughout the big continent, the supercontinent of Pangea, broke the continent apart into the modern continents that we see today by this very process of rift valleys forming, and then that basically starting to produce enough oceanic crust that it's lower down, it connects up with oceans that exist, and we get a whole new ocean like the Pacific, Atlantic, all the others we have today. So I hope you've been keeping track. Let's try a review question, something that might help you on the next test and just in your general understanding. So the question is, which features in tectonic activity would you expect to see at a divergent plate boundary in the ocean? So take at least a minute, read through all these answers, pause the video while you're doing that, and then come back and we'll identify the best answer. The best answer here to what features and tectonic activity you would expect to see at a divergent plate boundary in the ocean is B. The features you'd expect to see there and the kinds of activity, all of these work. So mid-ocean ridge, shallow earthquakes, faulting, and volcanic activity. Our question now is, which features in tectonic activity would you expect to see at a continent-continent divergent boundary? And the best answer to that question would be E. Of the options, it's the only one that has everything in it that works with a continental divergent boundary. So volcanoes near the boundary, shallow earthquakes, faulting, and rift valley.